Everybody, this is number 14 on section 5.3. So we have a poll. About 13% of adults are bettors. Okay, people that bet on professional sports. And about 48.8% of the population is male. Okay, so the question is, are the events male and bet on professional sports mutually exclusive? And the answer is no, right? You can be a male and bet on professional sports. There's nothing that prevents that. The way, being a bachelor or being married, those are two things you can't be both at the same time. Okay. All right. So part B says, assuming the betting is independent of gender, compute the probability that an adult from the country selected at random is a male and bets on professional sports. So to find the probability that they're both male and a bettor, we can actually multiply just the probabilities together. But the only reason we can do this is because we're told that being male and betting is independent of each other. Okay, so we just take the probability of being male, which we're given at about 49%, and the probability of being a bettor at 13%, and we just multiply them together to get this 0.06344. So about 6% are male and bettors, which is the answer right here. Okay, rounded to 4 places. Now, the third part C, asks us to compute the probability that an adult from the country selected at random is male or bets on professional sports. So that or ends up becoming really important. It's very different from the and here. Okay, so this is the probability that you pick a person and they're both male and a bettor. This is the probability that you pick somebody and they're either a male or a bettor or both. So there's going to be a higher probability here. Okay. And the way that we do or probabilities is we can just add the probability that the first thing happens plus the second thing happens minus the probability that the intersection happens. The reason that we would get rid of this intersection is because it's already included in both these. So it's like being double counted here. So we really minus it out once to just have these people that are male and bettors counted once. So again, the probability of male is 0.488. That's given in the problem. The probability that they're a bettor is 13%. That's given in the problem. The probability that they're male and a bettor is what we found from the last question. So just 0.0634. And then we add and then subtract that, and we get this. And then we just round to 4 places. Okay. So now the polling data indicates that 8.2% of adults in this country are males or bet on professional sports. What does that indicate to you about the assumption in part B? So this is, remember, an and. We found the and in part B to be about 6%, and they're saying it's higher. It's about 8.2%. And the assumption in part B was that being male, or the gender, and being male and betting on professional sports were independent of each other. So this kind of tells us that if this isn't the probability, that the assumption was incorrect and the events aren't independent of each other. Like there's a higher probability that there's either a higher probability that you'll be a bettor or a lower probability being better knowing that you're male. So knowing one of the probabilities gives you information about the other. I hope that helps a little bit.